Today we're going to be proving the reciprocal theorem and the reciprocity theorem. This is especially useful in thermal physics where you have equations such as the ideal gas law, which are variables that depend on each other. Let's write z as a variable, as a function of x and y. dz by dx subscript y. The subscript y just means that we're keeping y constant. Dx plus dz by dy, keeping x constant, dy. Let's say that we're moving along a constant curve, so dz is 0. And we can just rewrite all of this as dz by dx y dx is just equal to the negative of the partial dz by dy, keeping x constant, dy. Using the definition that the partial of dx by dy for all values of z is as we know that dz is constant, we can write that partial of dx with dy, keeping z constant, for all values of dy is just dx by dy. So we can use this definition to sub back into here. Divided by dy, we get dz by dx. Dx by dy is just this. So dx by dy, keeping z constant, is equal to the negative of dy x. Yep. Let's write this further. Divide by dz by dx, the partial of z to x. So dz now this goes for dx, partial of x with respect to y, but it also goes for the partial of y with respect to x. So just flipped, because we can do just the dy by dx as well. We get negative of partial of z with respect to x, keeping y constant. Partial of z with respect to y, x constant. This shows that the partial of x with respect to y, keeping z constant, is just the reciprocal of partial of y with respect to x. That's negative summation. With respect to x, keeping z constant. So, prove the reciprocal theorem that partial of x with respect to y equal to minus 1 over dx, keeping z constant. Alright, now let's prove the reciprocity theorem. So going back to this equation, we know that 0, as dz is constant, the function is constant, equal to dz by dx we can represent dx as just being dx, the partial of x with respect to y, times by dy. So when we sub this into here, we get partial of z with respect to x times by partial of x with respect to y, keeping z constant, plus times by plus partial z respect to y, x, all by dy. But this holds true for all values of y, so you can just get rid of that. 0. So you can move this to the other side, and then using the reciprocal theorem, flip it, and then times it, and we just get the partial of x with respect to y times by partial of y with respect to z times by, as multiplication is commutative, equal to -1.